Great. Hello, Kerstin. Thank you for being here. This is one of the lectures that we were planning to do in this tutorial for the HRI conference. It's called Roboludens, Game Design Techniques Applying in Human-Robot Interaction. And in this case, I have the pleasure to have here with me Professor Kerstin Dautenhan, which is the director of the research laboratories in social robotics here at the University of Waterloo. And we will be basically trying to talk about different design aspects of games when using social robots. So first of all, thank you, Kristen, for being here. And I hope we can have a really nice discussion about this topic.
Yeah, hello, John, and thank you. Yeah, I'll be happy to proceed with that interview.
That's nice, Kirsten. So, first of all, I would like to start really simple. For the people that they are not really familiar with both topics, game design and human-robot interaction. In this tutorial, we're basically trying to narrow down the scope and trying to see what makes this convergence interesting and important. So I would like to start to briefly ask you about this. Like, how do you see, like, why do you think it's interesting to do research in this convergence, game design and human robot interaction?
Yeah, I mean, I should honestly say that before I met you, in fact, at University of Waterloo, a couple of years ago, I never really thought about the definition of games. I never worked in game design. And I did in some publications use the words games and play basically synonymously, because as I said, I didn't dig into the literature on what actually are games back then. But play has always been very, very central to me. Why? Well, a lot of my work actually for more than 20 years involves children. So I've been trying to use robots to engage children, to help them, having in mind some therapeutic or educational objectives. Now, if you want to engage children, then really the best thing you can do is to ask them to play games with the robot. Now, play is also not just a way to engage them and it's fun for them, which is important because you want the experience to be enjoyable, but it also has a very important role in itself. It is when children grow up, it is actually through play how they learn the physical skills, motor skills. Other animals do that too. If you see young dogs or kittens or young birds playing, they are learning about the environment. They're learning about their motor skills. But in addition, it also plays a very important role in learning about emotions, going through experiences typically with another play partner or partners, if it is a group, and then through play to also learn about relationships, to learn about social interaction, to learn about communication. So play in developmental psychology, in fact, is very important, not just for physical development, but also for children learning about themselves, learning about others, and learning about their relationships with the world. I'm quite interested in literature and developmental psychology because my research generally is very interdisciplinary, often inspired by biology or psychology. And so for me, these two aspects, A, games, playful games are enjoyable and children love it. And B, it also has a value in itself. This led me to using games in many, if not all of my work, in particular when I worked with children.
And it's certainly interesting that you mentioned all these definitions and how, different people in different fields, they used to call things differently. So this is always hard to get across to the same vocabulary or same type of definitions, which is something that seems to be simple from a research perspective. But every time you try to do transdisciplinary research, you just realize how complicated very simple things like the definition of a game can be. And I'm glad you mentioned all of these important aspects of playing games, which is actually coming back to what Huizinga was mentioning about the Homo ludens and how we as human beings always have been surrounded by this playful and the importance of playing from a natural development point of view. And that also brings me certain questions related to, when you are doing all of this, or when you started doing all of this research in social robotics, I wonder, you know, when was that moment in which you kind of like realize, bringing games here can be like a very interesting approach to provide this natural interaction, especially when it comes to working with children. So you mentioned that a lot of your work has been with children. So I'm kind of like wondering when was that moment, or like what was that project that make you feel like, bringing games here will be an interesting approach?
It was in the late 1990s, around 1997, 1998, that I started research on robot-assisted therapy for children with autism. So my goal then was to think about how can you engage children with autism in games that they can play with a robot in a way that can also address some therapeutic or educational objectives. And the two pictures here that you saw, this is the Robota robot. It's a robot that was developed by Aude Billard. She's now a professor at EPFL in Switzerland. And we did joint work, and this was actually part of the PhD work of Dr. Ben Robbins at University of Hertfordshire. He did several studies with that particular robot, and we tried to design some games, for example, imitation games. So this robot could, for example, move its arms up and down and in different ways. And then we involved children with autism, and the game here, the objective was that they imitate. Imitation is learning about imitation skills is very valuable for children with autism. But I should mention that even before that, my PhD student back then, Ian Wary, he was together with me, we did the very first studies where we exposed children with autism to interactive robots. We used a mobile platform. It was not humanoid at all. It was very machine-like looking. And the games children could play with this robot were very simple approach and avoidance games. So, for example, when you stood in front of the robot, then the robot would approach you based on its heat sensors. But if it came too close, its infrared sensors would tell the robot to back off. So very, very simple, basically just these two behaviors, approach and avoidance. There was no sophisticated AI or decision-making in the robot. These two behaviors were really all it could do. But we found that children very quickly discovered how they could play games with the robot. For example, they could chase the robot. Maybe the robot was approaching, then the child could move closer, the robot backed up. The child moved even closer and the robot backed up. Or the children could play following games. They could, when they realized, oh, at this particular distance, now the robot would approach me, they could basically guide the robot through the room, for example. So what was really interesting with this very simple game is that, different from what is often being used in the normal definition of what makes a game, there were no objectives. There were no clear rules. It was up to the children to explore the rules. We did not tell them in advance that they could chase the robot or play these particular games with the robot. It was up to the children to explore the capabilities of the robot and how they could interact with it. The objectives were not explicit. They were hidden, so to speak, because turn taking is in fact something that many children with autism have difficulty with. So exploring that in this physical game of approach and avoidance, that was our main educational objective in that scenario.
And I think this is absolutely fantastic, just because it's coming across to the game design aspects and fundamentals that says basically the important thing is the experience. So the important thing is what the player's imagination is, bringing at the moment of playing the game. It's not about like the rules that you decide or that you design for them or the goal that you propose or the objective of the game, but how players are actually embracing the usability, how they use the game, how they play the game. So this is something that I'm particularly interested when it comes to designing all of these games for the robots. And in this specific picture that I'm showing here, I'm also super curious to see the technology. So you can see here, this is a modified doll like robot. So it's an I will be showing throughout the interview different robotic systems that you have been using, and it's very interesting to see the modification of the conventional elements that children most of the time they can recognize what they are, but then when you added like all the technological elements to make it feel like it's a social robot, that gives them probably certain clues about how to interact, or like how intelligent that system can be. So if we move now, as again into the nowadays we have like a lot of very sophisticated robots that they can do a lot of things, certainly, but they are also limited in certain manners. In this third question of this specific interview, I'm asking you about like how is the process, like when you start working with all of these robots and you have the sensing capabilities of the robot. How is your process of designing those games, and deciding the target, designing the elements that you will be using in the robot, and what is your conventional approach? Let's put it like that.
There is, in fact, no conventional approach. It is very multi-dimensional, this process. You need to look at it from many different perspectives. There is no linear sequence. Oh, we start with the objective and then we break it down, into its parts, and then we implement it and then we test it. No, it's a very, I would say creative process. And when I mentioned these different dimensions, so for example, one of the factors is what robots do you have available? You might think of amazing games, but then you realize, oops, the robots that I've got that I have available, but they will not be able to do those. So normally you start with a particular idea, having in mind. So for example, more recently in the European baby robot project, at some point in the discussion with my great team at University of Hertfordshire back then, I had this thought, oh, why can't we teach children with autism about visual perspective taking? Because a few days ago, I had read an article written by autism researchers where they argued that children with autism have difficulties with certain levels of visual perspective taking. What it means is that trying to understand another person's perspective, trying to understand what the other person sees, which is always different from what you yourself see. So we started off with that, and at the time we also had a humanoid robot called Casper. I don't want to talk about too many details about that robot now, but since you asked about the process, so we had this idea. We checked the robots we had available. We identified, oh, maybe with that robot, we could actually do that. We then also identified that the added value of using a robot would be that you can actually connect the cameras in the eyes of the robot to a computer screen. You can place the screen next to the robot, and then children can see what the robot sees, which is something you cannot do with a human being. If you have children with autism, for example, interacting with a therapist, the children will never be able to truly see what the therapist sees. But with a robot, you can then put a screen next to the robot, and in the first steps, facilitate the children to understand, oh, when the robot moves its head, its view actually changes, and then later on you would switch off the screen. So going back to the process, so we had those ideas, what could be done, what we wanted to do. Then we implemented a very initial scenario, a very, very simple one. And then we went to test it, because you have to test as early as possible in your design process with the actual, in my case, children who would later use this robot, or who would interact with that robot. We also involved also teachers. We were asking them for their opinion on this on these particular scenarios. So we got very valuable feedback from the either primary users or secondary users for that particular population. Then we went back to the lab and said, okay, can we maybe develop a series of increasingly complex scenarios? And this is what we ended up doing. But we always, during the whole stages of the development, we did testing. We had to do testing of the prototypes just to verify that we are on the right track, and that we get feedback from the children, from the teachers, and very often based on that feedback, we then modified our scenarios. So it is very much a user-centered approach, combined with technical development of robotics hardware, but also software, because sometimes you also need to modify the robots hardware if you want to implement some of those scenarios. And you always very carefully need to choose the robot, the right platform that has the right skills, the right capabilities, the right levels of autonomy that you would want in your studies.
And I think that's what makes this also very fascinating, because you really have to think carefully between this balance, regarding the game and regarding the robot. So you probably will envision a super, complex game with a lot of game mechanics. But if there's not a robot in which you are capable to, implement all of those features, then you really need to create an interesting balance. And I'm glad you are going through the details of like telling us a specific, what we call in game design, game mechanics. So what you just mentioned about like transporting the kid to see what the robot is seeing is actually a very interesting game mechanic that is one of those fundamental elements that we are always as game designers looking at for specific games that other media cannot provide. And this is a very nice example of something that you can do with social robot that is very hard to do in other media, like mobile devices or working with consoles and mediums like that. So moving forward, you were already explaining all of this process of like involving users, and that's what I think makes certainly some of your systems and your research so unique, because you're constantly doing what again we call in game design play testing with participants and adapting and iterating on that. And I just want to ask you a little bit more about this prototyping testing with the robots and the systems. How complex that can be. I mean, how much time normally does it take for you to get to, I don't know, an initial idea towards an interactive prototype that you can use for your experiments?
It takes a long time. When you talk about developing games, in particular for people with special needs, such as children with autism, you need to take a lot of care to get the games right, because you want them to be not just enjoyable, but also to address certain therapeutic or educational goals. So what I've typically had is an interdisciplinary team of people involved, people who had a background in HCI and psychology or cognitive science, in addition to engineers and computer scientists. And also, as I said a few minutes ago, with a very close collaboration with teachers, therapists, also autism researchers, psychologists, in order to get ideas from them.
What you're mentioning here is actually very well described here in one of your papers when you describe all the different scenarios. There's a specific figure there that I remember that is kind of like bringing out all of those things that you were mentioning, how you bring the consultation, the literature, how you merge all of them in trying to envision these scenarios.
Yeah, absolutely. This particular diagram looks a little bit complex, and that's because the process is complex, and sometimes it's very difficult to visualize this. So this is an example. I mentioned a very diverse interdisciplinary team. This was in fact part of a European project called IWOMAC. The coordinator was Gernot Kronreif from Austria, where we worked with a very large group. This is why this particular article has so many co-authors. They were actually all involved in the design of the study and many of the evaluations also that we did. And that was a three-year project with a large group of researchers. And sometimes, you know, you have so many challenges. You cannot just having, you know, as maybe one PhD student alone can typically not address that. You need a team. But that, of course, depends. If you want to do a project that's very, very focused, then that could indeed be suitable for an individual graduate student, for example.
What I really like from this specific paper that we're mentioning here is the level of details that you guys provided over there. Is like you provide a specific scenarios when you describe very particular game mechanics, like for instance the imitation game that you were just mentioning, the dance, how you include this movement of the body and all the physically embodiment of the robots to actually provide these playful ideas. So you were also mentioning like specific play types, the actors, what is the activity that they were going to be doing, the time, and what is the robot configuration, all of these fundamental elements that were in a very rich manner described in that paper. I think that was certainly very foundational in the way that how you can envision and describe these games when using shutter robots.
Yeah, absolutely. I mean, this took us a long time also in collaboration and discussions with the other researchers in the IWOMAC project. A particular challenge that we had in that project, you can see it here on the right when it says target group, because we did not only work with children with autism. AOT stands for autism, but we also worked with children with severe motor impairments. So SMI stands for severe motor impairments, but also MMR stands for children with mental delays or difficulties. And these three user groups are, of course, very diverse in their needs. For example, if you have children with severe motor impairments, then you need to design the games and adapt them according to the physical capabilities of the children. In the work that my team did at University of Hertfordshire, we worked with children with autism, so we had to deal less with physical difficulties, motor skill difficulties of the children. It was more about their understanding, for example, of turn taking or how to play collaboratively with another child.
And that's certainly very interesting, because you are now moving more towards the player. And that's actually the following question that I have here, which we are always looking like, what is the game user experience that we would like to provide when we design games for different populations. So you were mentioning you work a lot with children with special needs, and in this case, not only with this population, but beyond that population. I'm just wondering what are those elements that you normally use to evaluate in your experiments when combining social robots and game? What like your main insights in what you have found over here?
Well, there are typically different types of measures. We very often use subjective measures, more general for human-robot interaction studies, not limited to children with special needs. It is a standard methodology, a standard way how to do measurements, doing interviews, questionnaires, and so on. This might be suitable for some populations, but not for others. For example, in my work with children with autism, many of the children were nonverbal. So we could not do any interviews, and also questionnaires were not really feasible. That leaves us with some more objective measures, which I'm actually myself very, very fond of, because this is less about what people think, it's more about what people do and how they behave in an interaction. We did in many studies very extensive video analysis, where we on a often second by second basis, according to a certain coding scheme, we are coding certain behaviors in how people interact with the robot. And say in your experiment you have two different conditions, then you can compare, you can statistically compare the results of this observational data between these different conditions. But this is very, very time consuming. With certain studies that we did, it took us months, sometimes up to a year, doing the very detailed, fine-grained observational analysis. There are also ways to, depending on your objectives and the purpose of the study, sometimes you do not need to do an analysis second or even split second by split second. You can just generally, for example, just measure, are the children or are the participants in your HRI experiments, are they able to complete the task or not? So you would not have to do this in-depth video analysis. You would just watch the videos and then check, okay, here the child has completed the task. And we have also used this in many other studies with adults.
Okay. How useful are the robot's capabilities also to sense this type of performance and to provide any help for the evaluation?
I mean, the advantage of using a robot as opposed to another person in an HRI experiment is that you can log all of the data, all of the sensors from the robot, not just what the robot sees, for example, via its cameras, but also, for example, distances, or for example, touch. If your scenario, your game involves people actually touching the robot, and if the robot has touch sensors, it is able to log that data, to store that data, and again, you can later on analyze it. So you have a multitude of different sources of how you can evaluate the interaction.
And that's where I think this field and this convergence between games and human robot interaction is so interesting and so special, because that combination between the accomplishments and all the performance of users, with the subjective metrics plus what the robot can see and sense, makes, a very nice scenario to describe many or try to answer many different research questions, just because it's very rich, the type of interaction that you're having. When we have been going through this interview, and you're always mentioning your work in the field of therapeutic applications and therapeutic games, and in this case is also the convergence between games and social robots. So I'm just wondering here, like, how are you normally using all of these elements from human robot interaction, from psychology, from biology, to try to bring certain assistive tools for children with autism, with very different special needs?
I mean, typically our inspiration comes from either the literature, the autism literature. As I mentioned, when it comes to turn taking or visual perspective taking, there is literature saying that children have difficulties here. We also often get suggestions from teachers, which is for me one of the most interesting things. If teachers in a school approach us, the researchers, and say, oh, many of the children here in our class have difficulties in this particular area, can you make the robot translate this into a game? And then we say, let us think. And then we go back to the lab and try to implement it, if it is within the skill set of that robot, or if with very minor modifications we can realize those.
Teacher's wish list.
Yeah. So because this type of research, of course, working with children with special needs, trying to help them develop social skills, communication skills, this is a very interesting research agenda. But my research team has always had this very child-centered approach. We were always tailoring our games, not just with a view on, oh, we need to publish fantastic research coming out of that, but really thinking, okay, can we actually help the children? Can we develop the games so that children really enjoy it, that they leave the session with a smile on their face? So which is independent of any therapeutic objectives or educational objectives. It is more about the quality of life. I have often said to my researchers, keep in mind, if you work with children in general and with children with special needs in particular, their time is precious. We cannot just keep treat them as subjects in our experiments and expose them to certain situations and then observe what is happening. No, we need to provide them with an enjoyable experience, so that they get something out of that session, not just us as researchers in terms of research output, but that they gain something.
And I like certainly these reciprocal benefits that you're trying to give, because that makes me realize that sometimes I work a lot with physiological sensors, and I tend to put a lot of sensors and kind of like torture a little bit my participants in some of the games that I'm trying to evaluate. And I think this is a very interesting combination and synergy between achieving your research goal, but at the same time you're providing a very enjoyable moment for the participants, so they can actually take advantage of whatever you're doing. And you certainly were mentioning different robotics platform, and we saw the doll-like robot and all the robots that you have been working. And I think all the different pictures that we have been putting here on the slides, they actually reflect on how diverse has been the entire research journey that you have been taking. There's one specific robot that I think is very iconic from your research, and it's called Casper. And I just want to briefly talk here about Casper and the capabilities of Casper before closing this interview, because I think this is a very special social robotic platform that you guys have created, and you have lots of research on it. What makes Casper special? Like, why do you decide to design your own robot?
Yeah, Casper is an example of very iterative robot development. My team at University of Waterloo had been working on that since 2005. And we went through different cycles of the prototypes. And the reason is that basically during any study that we did with one particular version of the robot, we got feedback from the study itself with the children, or feedback from parents or from teachers with suggestions on how we should modify the appearance of the robot, the behavior, or the way how, for example, parents or teachers could conveniently operate and control the robot. So we started in 2005 because we wanted a robot specifically for children with autism that is not only a fully programmable robot. So whether we use it autonomously or whether we give the remote control to a child so that the child can actually see how he or she can control the robot. But we were interested in teaching about human-like communication and interaction. And we knew from the autism literature that that we wanted to, for example, teach about facial expressions and teach about social interaction, we needed a humanoid robot. But we couldn't have a humanoid robot that has very complex features. It needed to have realistic human-like features, but very much simplified. Because for children with autism, they get easily overwhelmed by social cues. If you just think about facial expressions, humans have several dozen of muscles in their faces and the way in how we control our faces. Human faces are really, really complex. We also have facial hair, eyelashes, eyebrows, or glasses, like in my case, wrinkles, Looking at faces are very, very complex and very difficult to interpret for children with autism. But Casper has a very simplified face. It has a few expressions. Here you could see it could open and close the mouth. It can smile. It can frown. But otherwise, it has a large variety of different gestures, head movements. In fact, if you're interested in technical details, it has 22 degrees of freedom. So although it looks like a doll, it's a very complex mechatronic system. It's a very complex robot. It's a fully programmable robot with also a number of different sensors attached. And in the latest version, we also use RFID technology with a set of cards. And if you hold it next to the robot, then a parent, like you can see here, or a teacher could very quickly change between different games, because after all, you are designing for users, so you cannot expect teachers or parents to be programmers. So you need to think also very, very carefully about the interfaces.
And that's something that makes really unique this robot, in which you can actually program it with all the different sensors that you have, and it has been a product of all of this research you have been doing back in the UK with all your team there. And I just wonder here, what is the future of this robot? Like, what are you expecting the robot to be? I don't know, in 10 years from now. How are you seeing the evolution of this robot and the uptake, of course, of people who might need the use of this robot?
Well, we need to see what the future holds, but I think Casper is still going strong. So yeah, I mean, hopefully it will at some point be accessible, so that many people can benefit from it. But this is now, since I moved to Canada 2.5 years ago, so this is now in the hands of my team back at University of Hertfordshire.
Yeah, I guess this is always the case with a lot of the things we try to do in research, and we always try to put the products and the different design and the systems that we do in the hands of people that might need. But there's always a lot of challenges in trying to get to it, and I will say especially when it comes to these type of social robotic systems. So just to finish, I also would like to conclude the talking about like the new things that this new experience here in Canada after you move from the UK. You have a well-established laboratory here. You have some resources, and then now you are a super well-known person in this field. So I'm just wondering here, like, where do you want to go? What are those exciting projects that you are doing right now? Mixing games and robots and interaction.
Yeah, I mean, and as I mentioned, I moved here to Canada 2.5 years ago, and now I have this wonderful research team in the Social and Intelligent Robotics Lab. some of my interests will, of course, continue because I've been interested in many topics for the past 20 or 30 years. So this is not going away, but I've also diversified quite a lot. In fact, one of the first projects here in Waterloo that you, John, were also involved in, as well as other research members and Professor Jen Boger, was a master project by Aishwarya Aravamutan. And here we were interested in intergenerational gameplay. So what that means is that we used the Pepper robot, Pepper, in order to create games that grandparents and their grandchildren could play together. And the vision here was that the robot would play the role as a mediator. So it's not that the robot is the focus of the attention. The focus of attention is between the two people playing together, but the robot would facilitate the interaction. We actually did a very interesting first study, but then unfortunately COVID-19 hit. And so this particular project came to a standstill. But we are hoping to, hopefully in future, to resume some of these ideas because we had already created a lot of other games that could be played. Another project by my MSc student Hamza Mahdi, and also together with Shahed Saleh, an undergraduate student, we developed a new robot called MyJ. It is a robot that was designed for children with special physical needs. So, for example, children restricted to a wheelchair and who have some upper limb difficulties in controlling their hands, for example. When I moved here to Canada, I noticed that basketball is really great here, you know. It's very big. Almost all the children here play basketball in summer in the streets. And so when we discussed, Hamza and I said, well, why don't we try to design a robot that can play basketball? I had never thought about that because clearly we cannot just from scratch build a robot that can literally pick and throw a ball. But Hamza developed a very clever design in order to circumvent that particular problem. So again, due to COVID-19, we have not been able to test the robot yet with children with special needs, but the robot has been completed, and we also did focus groups and interviews with parents and their children with special physical needs. And again, I'm looking forward in the future to actually also test that robot with children. Another area where many people are involved, many other, you know, I could name 10 or 15 other people, researchers, students, professors, either here in Waterloo or elsewhere. We are very interested in helping children who stutter. So using robots in order to contribute to interventions for this particular user group. And we are also in a separate project, very interested, my PhD student Samira Rasuli is working on that to help people, adult students, for example, in order to address some issues related to social anxiety. That's very much a project in progress, but I'm really looking forward in the future what the outcomes will be. And my PhD student Ellie Sanubari, again together with the whole research team associated to it, she's interested in developing robots as an intervention where basically robots are social actors that can teach children about bullying and how to address bullying. So we already published some research here, but again, this is work in progress. And finally, before I forget, sorry, John, but there are so many things we are doing. I've also recently teamed up with Greg Sullivan and his team in Vancouver from the Learning Disabilities Society, and together with a team of researchers in Waterloo, we develop games that children with learning difficulties can play. And so we are very busy at the moment developing some games that would be suitable together with the teachers in the Learning Disability Society. So to sum up, there are many projects that I'm very excited to be involved in, and I have a really wonderful research team here of postdocs, graduate students, but also collaborators, other professors here in Waterloo and elsewhere, to make that happen.
This is a really fascinating moment of of this type of research, in which we are seeing all the isolation and all the troubles, like COVID is providing, how all of these tools that we have been investigating throughout the years, and you have been pioneers, especially in the field of social robotics, how they can actually be used to certainly mitigate some of the aspects that we are carrying now during this pandemic times and beyond. So thank you so much for sharing all of those fantastic examples of like combining robots and games with different game mechanics. And I hope the audience was certainly able to grasp some of the fundamental elements that we were describing here: the robots, how to choose the robots, the availability of the robots, which type of technologies and design elements Kerstin has been used during this, I don't know, 20 to 30 years of journey in this field. And yeah, I would like to thank you, Kerstin, for all your time. Before moving forward, I would like to invite all of you to just visit the research that Kerstin and all the team have been doing here in the University of Waterloo in Canada. You can visit the website of the Social and Intelligent Robotics Research Laboratory, and all the research that she has been pioneering in the field of social robotics and games. So thank you so much for the interview, Kerstin.
Yeah, you're welcome. Thank you.
And hope to see you soon. Bye bye. Thank you for
Okay.
all.
Bye bye.